square root from this. What does this do? Squares this. What does this do? Applies natural log to the function. What does this do? It's looking for the tendency, for the pattern, where the function is going. So this says that the limit of the function as x approaches not equals 6 from the right is a number 5. If this is a number, we say that the limit exists. Limit exists. Also, in the same way, I can write the limit of f of x as x approaches 6 from the left. It's a power. Power plus means with number larger than 6. Power minus means with numbers less than 6. And this is still 5 because it's a number, the limit, which is the left-hand limit. Right-hand limit, left-hand limit. And we also have the third concept. Limit of f of x as x approaches 6 simultaneously from either side, we say, is 5. Okay, this is from either side. Okay, here's an example now. Here's a function.
So would the first one be the right-hand side?
Yes. So this is our 6. So now I would like you to tell me the limit as x approaches 6 from the right of our new function, and the limit as x approaches 6 from the left of this new function, and the limit as x approaches 6 from either side of this new function. What do you think? Someone I haven't heard from. Don, would you like to say something? It's okay if you're wrong. Trust me. Don, are you with us? You are muted probably.
6, I don't know.
Say that again.
6.
So we want the limit as x approaches 6 from the right of this function. What is the tendency?
Professor, what do you mean by that? I don't understand.
So as x approaches 6 from the right, where do you see the function going?
Downward.
Okay, where does it go? Excellent.
Negative infinity.
That's it.
Okay.
Excellent. Good. What about the other side?
Does that mean, Professor, I'm sorry.
Any question,
Does
please? Please, Manny.
Does that mean the function never touches 6?
It's a vertical asymptote. It will never ever dare to. The function does not exist at 6, yes?
Thank you.
Sure. Perfect. Good. Can anyone help with the other one?
Infinity.
Good.
Positive.
Excellent. Awesome. Can anyone help with the last one? What do you think?
Wouldn't it be negative infinity and infinity?
Careful.
Is that where it becomes undefined?
We use a different word. Does not exist. In short, DNE.
And that's because they're not going the same direction, right?
Excellent. The same point. Yeah. So a limit exists only if it is a number. If I can't give you that number, the limit does not exist. So this is DNE. This is DNE, but I cannot write the DNE. I have to write this in this case, and I have to write this. Here I have no choice, but it's still DNE. This is correct, but I cannot write DNE. I have to write negative infinity.
If that, so you have the two lines, the one in the, what is that the second quadrant, that one? But if like you took that top curve and you flipped it down with respect to like the X.
So if you want to put it like this.
Yes. Would it then be that it had a limit and it would be negative infinity?
But it's still DNE. The limit exists only if it is a number. Positive, negative infinity is a symbol.
So
okay, I was just trying to figure out like whenever it would be like. I think it'll be easier like when the example isn't infinity, if that makes sense.
Yes, it doesn't matter. If it's not a number, it doesn't exist.
So are you saying that if the limit as x approaches 6 from the right, if that's negative infinity, my limit as x approaches x is always does not exist?
I cannot write DNE unless they are completely opposite or different. If they go to the same direction, I still cannot write DNE, although it's DNE.
Right, I think for the third one I'm saying. So if
this one is DNE because one is positive infinity, the other one is negative infinity.
Okay, that's what I was
These two are also DNE, but I can't write DNE, although it's correct. Here I have to write negative infinity, and here I have to write positive infinity. But from either side, I have to write DNE. So just to make sure, can you upload this for me, please? Make sure that this is clear to everyone. And then I'd like to look at examples. Okay. So that's basically all we need to talk about. We just have to practice now. This is it with 1.1. So yes, homework will be due from 1.1. I'm sorry?
I'm not really getting it. I don't understand.
Which part?
How it just does not exist and how it's infinity.
So if we have a function like this, the limit from the left approaches a number, the limit from the right a different number, so it's DNE, the limit here. At 6, as x approaches 6 from either side is DNE. So this approaches 7, this approaches 6, or let me use a different number, 5, and the limit from the left is 7, the limit from the right is 5, so the limit from either side does not exist. Because the limit from this side is 7 and the limit from this side is 5. They're not the same number. So see, they're not going to the same point. So it's DNE.
Professor, how would an equation look if it's not approaching? So would it still be an arrow, or would it be like x equals 6? How do you know when it's not approaching and it's going to be an actual number?
I'm not sure I understand your question. So you're looking at the graph.
Mm-hmm.
So isn't this clear?
So pretty much it'll always be infinity and negative infinity or negative infinity.
If it goes to positive infinity.
Mm-hmm.
But here it doesn't. Here it approaches.
I think she was just trying to see if there is an example where we could see the answer be numbers instead of negative infinity or infinity.
Yeah, exactly.
Yes.
All right, so we just upload.
The limit from the
notes for
right,
this.
the limit from the right of 6 is 5. The limit from the left of 6 is 5. The limit from either side is 5. That's how we started. Is that what you meant?
Yeah, that's what I meant.
Yeah, that's how we started. First, I gave you an example in which the function was defined. At that point here, the function was not defined. It didn't make any difference. And then I gave this example with the vertical asymptote.
Okay, I see.
So now let's look at examples to cement our understanding here. And which page are we on? It should be at 112. So let's go to 112. And we'll see more examples right now.
So just upload our notes now?
Yes, just with the infinity. Okay. So we're going to look at examples right now, and it should be more and more and more clear by the minute. Okay, so we are looking at exercises 23 and 24. They already graphed this function for us. Thank you, I don't have to graph it. So let's answer these questions. So please follow and let me know if everything is clear now. So the limit of g, the function is g of x, as x approaches 4 from the left. Okay, 4 from the left. So here's 4. Can anyone give us the limit of g of x as x approaches 4 from the left? Yes, Ryan, because I haven't heard from him, I think.
So wouldn't it be -1?
That's it. So as x approaches 4 from the left or from 4 from the right, it doesn't matter. The function values get closer and closer from either side to -1. Awesome. You already answered the right. We already discussed that. It's also -1. So from either side is also -1. Great. Okay, so let's take a look at 24. At -2 from the left. -2 from the left. Manny, would you like to try that?
It's just that I cannot see the number, but I will try. So -2 from the left. It approaches -2.
-2 from the left. Function values tend to go closer and closer, closer and closer to 4.
4.
Good. Perfect. Now from the right. As x gets closer and closer to -2 from the right, anyone? The function values get closer and closer, closer and closer to 2. Excellent. What is the function value at -2? Can anyone tell us the function value at -2? I'm not talking about the limit. I'm asking the function value at -2.
2.
2, where the full point is. Final question. Thank you, Mallory. Final question. The limit from either side at -2.
Wait, I didn't get that part.
Which part?
At -2, it's 2.
The function value.
Mm-hmm.
It's where the full point is.
Okay.
This does not exist. This is a full point, so it's at 2.
Okay.
Good. So can anyone give us the limit of g of x as x approaches -2 from either side?
That will be the one undefined. That does not.
Exactly.
Right.
It does
wouldn't
not
exist because
exist.
there's a solid dot, correct?
It doesn't
Because there's
matter.
a-
The function doesn't have to be defined. We're talking about tendency. So the limit from the left is 4. The limit from the right is 2. So therefore, the limit from either side at -2 does not exist. Everyone okay with that?
Is that because the left and right have two different?
Exactly. Because they are not the same. Good. So let's take a look at another. You choose. I'll choose. Okay, so let's take a look at 51. This is the graph of function f. The limit from either side at 2. The limit from either side at 2. As x approaches 2 from the left or from the right, I mean simultaneously from the left and right of 2, the function values get closer and closer to, yes, Trey, go ahead.
-1.
Brilliant. -1 indeed. Awesome. Now the next question. As x approaches 1 from either side, 1 from either side.
Does not exist.
Exactly. Because from the left is positive infinity. From the right is negative infinity. From either side, I can only say D and E. Very good. Awesome. Great job. Okay. Let's look at 43. The limit of h of x, and this is h of x, as x approaches -2 from the right. The tendency of the function gets closer and closer to when x approaches -2 from the right. Kimmy?
1.
Yes. As x approaches -2 from the right, follow the function, follow the function, follow the function, gets closer and closer to 1. What about limit of x, h of x when x approaches 1 from the left? 1 from the left, 45. As x approaches 1 from the left, follow the function, follow the function.
Would be 2.
Follow the function.
4.
Yes, it is 4. Closer and closer, closer and closer, closer and closer to 4. As x approaches 1 from the left, the function values get closer and closer, closer and closer, closer and closer to 4. Well done. Okay. Now you see a lot of these examples. That's why I tortured you with, so to speak, with those piecewise defined functions from the beginning. So next time I'll show another example and we'll answer limits because we only have a few minutes. I just want to move on to other examples here. Okay, so here's another example. Let's take a look at 83. Can anyone help us with the limit of p of x as x approaches 2 from the left? 2 from the left.
1.21.
1.21.
Yes, indeed, 1.21. As x approaches 2 from the left, function values get closer and closer and closer and closer and closer to 1.21. Very good, awesome. From the right, the limit of the function as x approaches 2 from the right.
1.42.
1.42 as x approaches 2 from the right, closer and closer, closer and closer to 2. Function values get closer and closer, closer and closer to 1.42. What about from either side of 2?
Does not exist.
Correct, because the left-hand side is 1.21 and the right-hand side is 1.42. Which one do I choose? They are not going in the same direction. Okay, let's see what else is here. Okay, all the same. So these are extremely important. I mentioned that in the syllabus. You have these quick checks. I love them. I love them, absolutely love them. And they are extremely useful. So after you redo your notes, write them neatly on your, a different notebook or in your own notebook, whatever. Work on the quick checks. The answer is right there, and you test yourself with it. This is really good. Okay.
Excuse me.
Yes.
I know, so I don't know if I'm getting ahead, but I just want to know because, like, I see the ones with the graphs we've been answering, but about the ones without, do we?
Say that again. Ones with.
No, I mean the problems with that. So with the limits that don't have graphs on them, like
Yes.
those
Okay.
types of
I think we have time. We graphed like 4 already of these functions. Okay. So let's take a look at this big one. 77. So we have h of x. That's why I did this. So we can. That's why I was hoping that by now we're not going to have any difficulties with the piecewise defined function. And please, I'm begging you, do not use 3 tables. It's not a good idea for what follows in this class. So we know that this is negative infinity 0. We know that this is 0, 1, bracket parenthesis, and we know that this is 1, infinity. I have to find the domain and then the table. Can anyone give us the domain, please?
So it'd be parentheses, negative infinity, comma 0, parentheses.
If 0 is not here and 0 is here, I cannot break anything. So 0 is not here, but it's here. 1 is not here, but it's here. So what is the domain of?
So then it would just be negative infinity to positive infinity.
That's it.
Sorry.
Awesome. Awesome. So now I have to put 0, and I have to put 1. And remember, the 0 has parenthesis and bracket, and they are touching. And 1 has the same thing, parenthesis and bracket, and they're touching. And we know that this piece is with x plus 1. We know that this piece is with 2. And we know that this piece is with 3 minus x. Okay. So negative 1, and I get 0. I plug in 0, so I get 1. Here I have, no matter what I plug in, I have to have 2. And I plug in 3 minus 1 is 2, and then 3 and 0. I will graph in 3 different colors, again, to make sure that you understand that if you overlap these, it means that you really have to work hard on this graph. Okay, so this is a straight line. So I already know the limits, right? As x approaches 0 from the left, what is the limit of the function?
1.
Yes. That's why this table is so important. I know you're trying to use a different one. That's fine too, but you're not going to understand what I'm doing. So as x approaches 0 from the right, what is the limit?
2.
Yeah. What is the limit from the left of 1?
2.
Good. What is the limit from the right of 1? Does this limit exist from either side?
Yes, the limit from either side would be 2.
Exactly. What about here? Does the limit from either side exist here?
No.
No. So you don't even need to graph. If you're using the table I presented from the very beginning, you already have the limits. So negative 1, 0, and the 0, 1 with an open point. I'm done with this color. I'm moving on to another color. So 0, 2, it's a full point. And 2, 1, so 1, it's a full point. It's open on this side, but I have to fill it. Okay, so I'm done with the second color. And now I'm using whatever this is. So 2, 3. Okay, it's very clear that the limit from either side of 1 is 2, but the limit from the left of 0 is 1. The limit from the right of 0 is 2. So the limit from either side of 0, as x approaches 0 from either side of, I'm sorry, it was h of x. H of x is d and e.